the previous classes, we discussed about the important concept of reflection. Today, we are going to discuss the refraction of light. What is known as a refraction? The bending of light when it travels from one medium to the another. That is called a refraction. Refraction is the phenomenon of changing the direction of propagation when it travels from one medium to the another medium. Write down the definition. It is the phenomenon. Refraction is the phenomenon of changing the direction of propagation of light when it travels from one medium to the another medium. In other words, bending of light. Simply, you can say the refraction is bending of light when it travels from one medium to the another medium. See the diagram. This is the incident ray. It falls on the surface, which separate the two medium at O. After that, the direction of light bends like this OB. If you draw the normal to the point of incident, it will be, say, N dash. Here, we are assuming that the light travels from denser medium to the rarer medium. The bending of light will be towards the normal. Actually, the path of the light will be in the straight line. Due to the change of medium, it will be a straight line like this. It is represented by the dotted line. Due to the change of medium, it travels from A O to OB instead of this, say, A dash. Let I is the angle of incident. R is the angle of refraction. This phenomenon is governed by the law of refraction of light. It consists of two statements. The first statement, the incident ray, the refracted ray, refracted ray, and the normal to the point of incident perpendicular to the surface which separate the two medium or lie in the same plane. First statement is incident ray, refracted ray, and the normal at the point of incident to the refracting surface. Or lie on the same plane. That is the first statement. The second statement, the ratio of sine angle of incident sine angle of refraction is constant. The constant is called refractive index. It is denoted by the letter mu, sometimes n. The statement, second statement is called Snell law. Sin I divided by sin R, that is equal to mu, or in other words, mu prefixes 1, suffix 2, or mu is equal to 2, 1. That means it can be written as mu 2 divided by mu 1. Mu 1, 2 or mu 2, 1 is refractive index of the medium 2 with respect to 1. Mu 2, 1 is refractive index of the medium 2 with respect to 1. That means the ray coming from 1 to 2. That is the important point. This is called the Snell law. Another important relation, say mu 1, 2 is the reciprocal of mu 2, 1. R fluid. Mu 2 1 is equal to mu 1 2. So you go to the, have you copied? Copy பண்ணிட்டீங்களா? Kindly respond, students, kindly respond. Next term, absolute refractive index. Absolute refractive index. It's the ratio of general expression, refractive index of the medium. We are comparing the medium with the air. Refractive index of air or vacuum. It's also defined as another important relation, C by V. C means speed of the light in vacuum. Can be written as further as mu 1 2, that is 2 1 is equal to mu 2 divided by mu 1. Mu 2 can be written as C divided by V2. V1 can be written as C divided by V1. As a result, mu 2 divided by V1 is V1 by V2 in terms of velocity or speed. See this refractive index, it's inversely proportional to the speed. Speed of the light in medium medium 1 divided by speed of the light in medium 2. That means mu 2 divided by mu. Students, another important point, take down this. When the light travels from one medium to the another medium, frequency remains constant, but its wavelength as well as velocity changes. When the light travels from one medium to the another medium, the frequency remains constant, but its wavelength velocity changes. Frequency constant, wavelength as well as velocity changes. Okay. Shall we go to the next concept?
Yes, sir.
Okay.
Sir, wait, sir.
Ah. Okay. Have we completed, ma? Hello.
Okay.
Okay. Next one. See this diagram. All the students kindly see this diagram. In the first case, the light travels from rarer medium to denser medium. Do you know the difference between the rarer medium and the denser medium? Rarer medium is the medium in which the speed of the light is more. Next. Okay, all of you listen. See the diagram. The light travels from rarer medium to the denser medium. See, if there is no intervention between the rarer medium and denser medium, the light would travel in a straight path shown by the dotted line. The மாதிரி light வந்து the ray வந்து straight-ஆ போயிட்டு இருக்கு. When it travels from rarer medium to the denser medium, the path of light will bend towards the normal. This is the normal. It is bent towards the normal. This is the one condition. Suppose if the light travels from denser medium to the rarer medium, it bends away from the normal. See this diagram. Here, in the top, this is a denser medium. This is the rarer medium. This is the incident ray. When it travels from denser medium to the rarer medium, see, actual path will be like this, shown by the dotted line. Shown by the dotted line. When it travels from denser medium to the rarer medium, it's away from the normal. It is away from the normal. That is an important phenomenon. Draw these two diagrams. Note down this. When light travels Have you come? Have you finished? So this diagram also. All of you see this next picture. The left hand side of this. See, the light travels through the different mediums. Here, in the first condition, the light travels from air to glass, and then it travels from glass to water. When the light travels from air to glass, it is refracted. When comparing to the air, glass is the denser medium. Therefore, it is bent towards the normal. This is the normal at the point of incident. Actually, the path would be like this. Since it is a denser medium, this path is bent towards the normal. Say this one I, this one R1, I1, R1. Again, it is incident on the water surface. And comparing to the glass, it is also, see, water is rarer medium. Water is rarer medium compared to the glass. It bends away from its original path. After refraction, it is incident on the interface of water and the air. Finally, it is again refracted and bent away from the normal. It is also, it travels from denser medium to the rarer medium. Water is a denser medium, air is the rarer medium. Now, using the Snell law, take the first condition, light travels from air to glass. The refractive index is written as sin I divided by sin R. Sin I divided by sin R. For the medium 1, the angle of incident I. For the medium 2, angle of refraction R1. Then second condition, the light travels from glass to water. Mu prefixes 2 to 3. It travels from 2 to 3. Therefore, the angle of incident Ri to R. Here, Ri is equal to R1. This R1 is equal to, again, the angle of incident. This angle is equal to this angle. The angle of refraction in the first condition is equal to angle of incident in the second condition. R1 எப்படி எடுத்துக்கிறோம்? Ri2 ன்னு எடுத்துக்கிறோம். அதனால both are same. கரெக்டா பார்க்கணும். பாருங்க, இருக்கணும் I2 ன்னு இருக்கும். Here the I2 is equal to R1. This is the second phenomenon. Here also the R2 is equal to what? I3. This is I4, third condition. This I3 again is equal to R2. This one R4 is equal to I1. Now using the Snell law, mu 2 to 3 is equal to sin I divided by sin R1 divided by sin R2. Similarly, the refractive index from the medium 3 to 1 is sin R2 divided by sin I. When you multiply these refractive indexes, that will be equal to 1. When you multiply all the refractive index from 1 to 2, 2 to 3, and 3 to 4, that will be equal to 1. This is a very important property. That means the first medium and the last medium are same. See the diagram? The first medium is air, the last medium is also air. Therefore, this angle of incident, this line is parallel to this line, because initial and final refracting medium are same. Kindly note down and draw this diagram. When you multiply all the refractive index, it will be equal to 1. 1 to 2, 2 to 3, 3 to 4. That is equal to sin I divided by sin R1 into sin R1 divided by sin R2 into sin R2 divided by sin I. The sin R1 get cancelled. Similarly, sin R2 get cancelled. The final will be sin I divided by sin I. That is equal to 1. Students, can we move further?
Yes, sir.
Okay. Next concept in this topic, apparent depth and normal shift. See, when you look into the bowl of the water, it does not appear to be as deep as if really is. Also, when you look into the slab of the glass, the material below the glass does not appear to be as thick as it really is. This is due to the refraction phenomenon. That is due to the refraction phenomenon. நீங்க ஸ்விம்மிங் பூல்ல போய் பாத்தீங்கன்னா மேல இருந்து பார்த்தா ஸ்விம்மிங் பூலோட டெப்த் ரொம்ப கம்மியா இருக்கிறது மாதிரி தெரியும் than the real depth. Similarly, when you see the object placed below the glass, the object are very close to the glass. It is due to the refraction phenomenon. It is due to the refraction phenomenon. Here we are going to relate the actual depth and the apparent depth. The apparent depth is lesser than the actual depth of the swimming pool. Consider a point object placed in a water. The point object is, see the diagram. This is the denser medium, say water, in which a point object is placed. This point object is at a distance AO from the normal. O is the point object. That is the real depth. The rays coming out from the point object normally, without any bending, it passes through the line AA dash. Point object ray of light perpendicular travel achna, without bending, it travels as AA dash. Suppose if any ray of light coming out from the point object at an angle, say, see the diagram. This is the denser medium. It incident at the point B. This is the normal. N dash is the normal. It will bend because due to the change of medium. Since water is a denser medium, the refraction will be outward from the normal. இப்போ ஆக்சுவலா இந்த லைன் இப்படி போயிருக்கணும், நேரா போயிருக்கும். இது எப்படி இருக்கு, பெண்ட் ஆகுது. bending away from the north, away from the north. See, from the point C dash, sorry, C dash, if you draw the line, if you project the line from B, it will be B O dash. It will intersect the perpendicular line coming from the point object. It will intersect at the point O dash. When you measure this line, O dash, that will be the apparent depth. And the depth தான் நமக்கு கண்ணுக்கு தெரியும். Actual depth வந்து என்னது? AO. The apparent depth is AO dash. This is due to the refraction phenomenon. Okay. The ray of light OB incident at the point B, I is the angle of incidence. BC is the refracted ray. With respect to the normal, the angle made by the refracted ray is R. When you project the refracted ray in a backward by the dotted line B O dash, it will intersect the vertical line O A dash at O dash. This line makes an angle I with respect to normal. That is a perpendicular. This line parallel to this line. Therefore, this angle is equal to the angle made by the incident ray with respect to the normal I. Here also, this line makes R with respect to A dash O. This angle also equal. It is enough to know the formula to find out the apparent depth. Mu is equal to, all of you listen here, mu is equal to refractive index of water with respect to air is equal to real depth divided by apparent depth. Very important relation. Therefore, apparent depth is equal to real depth divided by refractive index of the water with respect to air. Remember this formula. The another formula to find out the difference between the apparent depth and the real depth. Say D is the difference between real depth minus apparent depth where x is equal to depth of pool or depth of water. D is the difference between real depth and the apparent depth. Understand? Okay. We'll move to the next concept. Next concept is total reflection and the critical angle. Consider the ray of light coming out from the denser medium to the rarer medium. See these diagrams. See this diagram. A point object is placed under the denser medium, say water. When the light travels normally from denser medium to the rarer medium, it will not bend. It will pass us through this straight line. Suppose if the light travels at an angle, it will incident at the point O1. See the diagram, all of you see the diagram? It travels from denser medium to the rarer medium. After refraction, it will bend away from the normal. This is the normal. It will bend away from the normal. Here, the angle of incident with respect to the normal I, and the angle of refracted ray is R with respect to the normal. Consider another ray of light incident on the surface at O2. This angle of incident is greater than the previous one. As a result, the refracted angle is also increased. It will away from the normal. This is I dash, this one R dash. If you increase the angle of incident further, at one stage, at a particular angle, it will surface, the refracted ray will surface the rarer medium and the denser medium. It will passes at the interface of the rarer medium and the denser medium. That means the angle of refraction is 90 degrees for the particular angle of incident. That angle of incident is called the critical angle. The critical angle is the angle of incident of the refracted medium, angle of incident of the light when it travels from the denser medium to the rarer medium, at which angle of refraction is 90 degrees. For the given angle of incident, the angle of refraction is 90 degrees. When it travels from rarer medium to the denser medium, that angle is called critical angle. அதாவது ஒரு particular angle, the refraction light வந்து என்ன ஆகும், parallel interface வழியா போகும். பாருங்க, இது இப்படி பெண்ட் ஆச்சு, இது இப்படி பெண்ட் ஆச்சு. ஒரு பர்டிகுலர் ஆங்கிள் it will bend over the surface of the rarer medium and denser. எந்த ஆங்கிளுக்கு இந்த மாதிரி வருதோ அந்த ஆங்கிள் தான் கிரிட்டிக்கல் ஆங்கிள் சொல்றோம். Here the angle of refraction is 90 degree. Okay. Suppose if you increase the angle of incident more than the critical angle, இப்போ இங்கே படுது next. If they increase the angle of incident more than the critical angle, the refraction will be again inside the same medium, denser medium. உள்ளேயே வந்துரும். This phenomenon is called the total reflection. Total reflection is the phenomenon of refracting the light into the same medium when the angle of incident is greater than the critical angle. Understand? Any doubt, student? Okay. See, draw the diagram and write the definition for it. நம்ம என்ன பண்றோம், angle of incident கொஞ்சம் கொஞ்சமா increase பண்றோம். ஒரு particular angle the refraction overlap the interface of the two medium. At that particular angle is called critical angle. If you increase the angle of incident greater than the critical angle, the refraction will take place again inside the same medium. This phenomenon is called total reflection. When a ray of light traveling from denser medium to the rarer medium is incident at the interface of the two medium at an angle greater than the critical angle for the two media, the ray totally reflected back into the rarer medium. This phenomenon is called the total reflection. Have you finished? Only one concept is there in this topic. Next class, we will solve the problem related to refraction. Have you completed? Okay, students, thank you for attending the class. We will see tomorrow, day after tomorrow. Thank you.